How's it going, everyone? Welcome, Javier Gonzalez here, and today let's going to keep looking at these three pillars of JavaScript to be competent JavaScript developers, and the reason of exploring and looking at that. So, in today's video, let's going to now look at that particular example of the coercion. I don't think that I have that, right? Because we went through all of this. Yeah, Java I don't think that I even have a repo set it up for that. Yeah, I don't think that I have a repo from that. There you got it. Right. Yes, good. Type exercise. The object that is the coercion, which is this. So let's get into this, right? I think it's this one. Okay, good. Let me open that up here with code or cursor, right? I got cursor here. I don't think I have that open now because I use is now. What did I use? Cursor. I think I use Visual Studio Code to do that exactly. Yeah. Okay. Let's get into this. All right. So follow me here. Yeah, follow me here. How can you follow me? Using warp? Yep. Nope. Is not warp. Is in fact this one. Nope. Website from scratch. Let me open up here. That is code. Go. For Visual Studio Code. There you got it. And here we are. Okay, cool. All right. There you go. All right. So the TLDR of all of this is that this course is for those who wants to be competent in JavaScript as a way to understand what is the fundamental, what are the pillars. So anytime that you encounter yourself with reading or writing particular code, you know what this tool is doing for you. So it becomes not a dangerous stuff because since you already know what's going on, and therefore you cannot focus on things that are effective, aka is the business logic and understanding the code and understanding the intentions of whoever was the author of this, or even yourself. Now, because of that, and since JavaScript developers are unfortunately known as professional guessers, right? This is the only profession that I will argue that is doing that. So if you're an architect and you are trying to design, or you are designing a building or building one, you want to be precise because otherwise that is gonna fall out and kill people. So this is a part of this course to understand now the three pillars of JavaScript. And any time that we need to do something, we do that with intention. We do that in a deterministic way because we understand now is, for example, the type systems, the abstract operations, the primitive, in the philosophy of coercion, as well as the scope, the function definition, and the function expression. and also is the object-oriented programs or the objects-oriented paradigm here. So once we know this foundation, we can merge that with the object-oriented programming as well as the asynchronous nature of JavaScript, and also with the functional approach. All of these different pieces of informations or models are going to be now condensed, right, into one course. But at some point perhaps I might do that, who knows. But right now I'm focused, my attention is on doing is this, on the fundamentals of the pillar of the JavaScript, specifically the type cohesion, because a lot of the time we tend to ignore or say, for senior developers, it's like, hey, I prefer to use a triple equality, right, and go over the type cohesion because I don't care about that. It's like, that's not for me. And that's a neglected part of you being a competent JavaScript developers, because this is something that's happening, you like it or not, and not only that, is that if you don't know what is this doing, this is a dangerous stuff, because things becoming this unpredictable. And here, as a JavaScript developer or a system design, we want that core principle, predictability. So this is it. So on previous lessons, we look at the way of how we are going to organize is this course, type system, the scope, and the object-oriented programming. Then focus our attention to types. What is the primitive, which is atomic values, all right? And also is what is the primitive, different type of primitive that we can have. Also is the corner cases with primitive, and how can we detect is the particular value, because variables doesn't hold values or types, values does. And we look at the most common, undefined, null, number, string, boolean, symbol, big int recently added, as well as objects that are not primitive, but I mentioned all of this primitive, right? And also these corner cases when you trying to evaluate, for example, is the value of a null using the type of, and why does it return you an object, and also another corner case like when you try to add 0.1 plus 0.3, why this give you a 0.30004. This is the TLDR, is because we have a fixed limited memory. This is due to the representations of the binary system. So I actually would like to go into that. All right. I don't think exactly. So because computer memory is limited, and representing 0.3 in decimal is not precise. So try you to divide 1/3, 1 by 3, and how many 3 it give you, 0.3, 0.3, 0.3, 0.3, 0.3, and just so on and so forth. So binary floating operations, binary floating a point cannot accurately represent that number. So computer has to, computers, when the code is compiled or interpreted, it round that to the nearest value, especially 0.1 and especially 0.1. So I will also try to bring that up here. Okay. If I do this, Of how computers store the decimal number in binary floating point format. And here's what happening. 0.1, 0.3 cannot be represented exactly in binary floating points. Exactly. Just like can be it's interesting. And that's a part of mathematics here. Because computer memory is limited and representing 0.3 in decimal in a binary floating point binary floating point, that's the problem here, and representing 0.3 is not in fact is this one. All right, because it's not precise. Try to divide by 3 and see how many 3 you can get. Okay, and decimal binary plot is not precise or cannot accurately represent that number, so computers, when the code is compiled or interpreted, it round it to the nearest value. So there's some couple solutions to that as a way to round that or to fix that. Okay, why am I bringing this here? Because since we are now evaluating these corner cases as well as the type of emptiness, which is what is undefined, what is undefined, what is Jesus, what is undefined, what is what is undefined? Okay, so what is undefined? What is undeclared? Okay, so what is undefined? What is undeclared? And what is uninitialized? Right. So undefined is something that you create, okay, but it doesn't have any value. Okay, it's never so. Whereas undeclared is something that you don't even create that. Where the term uninitialized is something that you this is from the block scope, something that you haven't, something that you even have to, something that you initialize but without an undefined value. Again, this type of kind of emptiness is important to understand. Very useful. I will definitely ask these basic kind of questions for an interview. Absolutely. Absolutely. Completely. And the other is some special values, right? Like positive 0, negative zeros, nan, what nan represents, which is a this is a non-numeric representation. This is a non-valid representation of a number. And this comes from the Institute of Electric and Electronic Engineering, stands the IEEE. They have now a spec called 754 where explicitly now define this, right? And because these numbers are expressed in 2 power 53, all right, which means that it's a 9 followed by 15 digits. This is the safe representation of a number, all right? We're talking about is quadrillion. And because of that, if you want to now represent more than 15 digits, so for example, astronomic distance or finance or cryptography values, it turns out that you will need now is big int. And big int kicks in as another primitive here. So we also look at how to determine the type of this value in by exploring now here how you can determine that a value is a positive or a negative, all right? And the way to do that is by saying, hey, I'm going to now take a look at that number. If that number is equal to 0, and if I divide that number by 0, it gives me minus infinite. It turns out that this is now a negative 0, all right? So I'm going to evaluate that expression. And the other is, if I want to check that a value is nan, because it is property, the property of a nan, it's say, hey, this is the only type of value that is not equal to itself. Therefore, we can now check if they are different. So if this is a nan, all right, if this number that we receive is a nan, well, therefore we're going to now check if both of them, if both of those values are not equal to itself, are not equal to the identity. That's what we check here with is nan and negative 0. So then we talk about now is the abstract operations, all right, in which is the way of how now the conversions happens or the coercion happens. There's a lot of abstract operations that ECMAScript does behind the scenes. This is something that is not exposed to ourselves as developer. This is something that is conceptually what's happening when it comes to the language try to know the type of this value, the dynamic nature, all right? And I think this is one of the beauty and the powerful of this language, that you can, as long as you know how the things work, you can delegate that to the language, all right? And then you get the desired outcome. So you are more deterministic in that. And not also, you are more explicit when you want to a coercion happen. So the most common abstract operations is to primitive, okay? That is invoking now is a particular hint that is going to receive, which is, hey, if this is a string, I'm going to run first the toString and then the toValue, or the value of, all right? If this is a number, I'm going to do the reverse order. Okay, this is only to get is the primitive. And also, an important thing is that it's going to do that in this recursive way. So if for some reason you are passing now an object and it's trying to coerce that into a primitive, it's going to do that until a primitive is determined here. So this is the primitive, the other is the string. We're quite familiar with this, or the stringification of numbers. The corner cases of that is for positive and negative values. Okay, the stringification of primitive, something that, let me actually show this stuff here. Oh my God. There you got it. As here, right? So the stringification of primitive, there's undefined, null, or a true value, or a false, or a number, even a symbol. That's also interesting. I would like to check how a symbol transform. Okay, let's take a look at this. Let's definitely take a look at this. All right, and you say, hey, string, what do you see? How do you transform this symbol stuff, right? So now here a symbol, let me for example say, hey, this will be a variable called symbol x, right? And with the string you say string of symbol x, right? And now it is interesting because it transforms into something called function symbol. All right, it transforms into a function symbol, into a string function symbol. with native code. Most of the time we don't use this symbol, all right? And to me it's quite interesting that we don't use that. That go beyond the scope of today's video, all right? But this is the stringifications of primitive. The other is a stringification of numbers, all right? And what happens there is, and last but not least, is the stringifications of objects. Well, there is an object, which gives you now this object, right? Surrounded by square brackets. And the stringification of arrays, which gives you now these weird behaviors of empty strings, you know? And here's when empty string becomes the root of all evil. Here, empty string becomes the root of all evils, bro. All right? Becomes the root of all evils, bro. So, now, the other abstract operation is the toNumber. So toNumber is say, hey, I'm going to now is transform whatever value that I'm getting here into a number, or coerce that. So we look at the numberifications of string, all right? That usually is depend of the use case. So if you pass something that is not a number, it's gonna throw you an N. If you pass now an empty, it gives you now 0, and this is when things started to mix. Okay, this is when empty values and zeros started to become is an issue for that. All right. So yeah, the numberification of a string. So you pass now an empty string, it converts into 0. If you pass now an empty, if you pass 0, okay. If you pass now an empty, an array string and try to, Jesus. This is the numberification of a string. If you pass an empty string, it transforms into 0. The stringification of objects, for example, like array. If you pass now an array, it gives you a 0, right? Like this, an empty string, exactly. Okay, an empty string, and an empty string is now translated to a 0. Okay. So if you pass now a 0 or a negative value, transform into properly to that. If you pass now a lot of leading zeros and with a number, it gives you now is the number, all right? And if you pass now even point floating operations, it gives you now, it can represent is this point floating decimals, which is great. 0 point or 0 point to left or right, actually it's not good at representing that. It gives you 0. If you pass even a representation of a number, give you that. And this is the numberification of a string. What happened with the numberification of Boolean? Might be quite intuitive. True, 1, false, 0, null, 0, and undefined is nan. You have to be careful here, okay? And the other is the numberification of objects. So this is actually quite straightforward. With object, it's a for any object or string by default, it's going to run the value of and then try to coerce that into a string. So in other words, if you're trying to say something like this and say the number of an object, what will be the number of an object? Okay, what do you think that might be the expected output of this? What is the mechanism here? It will try to coerce that. It will try to coerce that by calling into the toNumber, okay? And the toNumber say, hey, if I can transform this into a number, all right, I'm gonna throw you now another number in this case. So it makes a lot of sense. This is for objects. This is true for objects. But what about arrays? In this case, if this is an empty array, I think this will give you 0. Okay? If this gives you 0, if you pass now a number, it will transform that properly. You know? If you pass now a number like this, say no, this is not a valid number. If you pass now this is interesting. This is the non-verification of object, in this case arrays. All right. If you pass, for example, a null array, makes sense. Undefined makes sense. You pass now 1, makes sense. If you pass now on a string here of an array, makes a lot of sense. If this, for example, has this following shape, it gives you this. All right, it's not a number. And you might wonder, why do I even care about this? You know, if this is -0, it gives you -0, and this is +0, it gives you +0. All right. If you pass now this, of course you're not going to transform that, but you can get the idea of this. All right. This is the numberification. This is the numberification of this specific use case, the corner case with array. Okay, yeah, this is something fun. Yes, good that you know. Good that you know that, bro. It's like, why do you even care about this? Because when you talk about now the another abstract operations like to Boolean, where unlike the to string or the to number, that is it follow now an algorithm way to do things. Here with to Boolean is more like the hey, I want to. It is a lookup table. It is a lookup table that say, hey, let's go to now define this falsy value first. So if this is an undefined, null, empty string, nan, positive or negative 0, then the value becomes false. All right. So you say, okay. So anytime that you use, or anytime which is here, so anytime that you have a value that is not a Boolean, okay, so anytime that you have a value that is not a Boolean, and Boolean values are true or false, period, that's the only possible values that you can have, all right, the type of value. So anytime that you need a, or anytime that a Boolean value is needed, or anytime that you use, or anytime that you have a value, okay, so anytime that you have a value that is not a Boolean, all right. So anytime that you have a value that is not a Boolean, okay, where a Boolean value is used or is needed, okay. So anytime, okay. So anytime that you have a value that is not a Boolean, that is used in a place when a Boolean value is needed, this operation happens. So for example, the if conditions, the while conditions, right? The Boolean here is, for example, is this known list of falsy values. So for example, if this is a positive value, or a negative 0, or a null, or an undefined, or an empty string, or a nan, all right? So all of them will be false. This is more straightforward to understand that, you know? This is a more straightforward thinking here. All right, so far so good. Now, what happened when we try to use those values to understand the coercion or the counter cases of coercions? So he looked at the TLDR of that is that any time that a binary operation is happening, and by binary I mean is like now evaluation that a coercion or an addition operation is happening, string concatenation is preferred rather than the number. And this is true. You can take a look at the runtime semantics, all right, to see that, hey, this is what's going on in this algorithm, this abstract operation here. So the point of this is try to make it as much clear as possible. Sometimes this is preferred, or you can delegate that to JavaScript because you're sure that you know what's going on here. And perhaps that's the desired behavior that you want. And here is the trick part, and here is the real deal. Now, this is number to string, all right? If you want to transform that particular number into a string, you can use the plus operator, all right? Or the number operator. I will prefer to go with the number, which is much more explicit to that, all right? And the other is the string to numbers. Okay, anytime that you want to transform or coerce a string into numbers, yeah, you can do this number operation, all right? Or the number to a string is preferred. You can do this, but I wouldn't recommend you to do that. Sometimes that might be the preferred state, because now you are being explicitly about what's going on. However, here we know that when it finds this interpolation, it's going to coerce that into a string, all right? And this is true, and I really love about this, because this is actually telling you what it's going to do if you pass me any value here, no matter which value it might be. It is a primitive or an object, I'm going to coerce that into a string. And what is the possible value that I can have here? Well, if you pass me undefined, I'm going to print that undefined, null, or true, or false. If you pass me now a positive or a positive value, or a negative 0, I'm going to now show you that if you pass me not a number, I'm going to render that. If you pass me now an object, I'm going to stringify that into an object. Might be not useful, all right? Or if you pass me now an array, I'm going to now transform into an empty string. But now we know what's going on. So anytime that you see this kind of stuff, you say, oh, and a string concatenation is happening, or a string coercion is happening. It's calling behind the scenes the toString methods. This is for templates, for template literals, all right? Good. The other is for numbers. You want to coerce the values, all right? And this is a very widely common use cases here. A very widely common use case, as you may guess. And the other is the toStudent here. Now, or the plus operator, when you want to try to coerce the string into a number. So the other is that with booleans, and I mentioned it and I hit the brake here, because this is when now most of the time perhaps we do that in an automatic way, autopilot way, but we cannot describe that. And I think that if you cannot describe that, it'll be hard for you to explain that. It's not impossible. There is a lot of things that we cannot describe that we understand. Okay. However, if you're going to be a profession, a profession, that which is where the word profession comes from Old French, which is that you take secret vows upon entering into this religion. Back in the old French, around 12th century, 13th century, okay? But now we are entering in this profession, in this field, in this area of knowledge, and we took secret vows to get into this. So that is the reason why, if you want to be a competent, you need to understand this, all right? What happened with the string, the number of the string to number, and the Boolean side, okay? And how you can handle those corner cases with Boolean, right? So for example, like this. So it will be preferred to say, hey, whatever value that you give me here, all right, I want to coerce that into a Boolean. And we know what are the Boolean false, or the falsy and truthy values, okay? So this falsy and truthy value, it can be either a 0 or a 1. If this is true, 1. If this is 0, 1. If this is undefined, then, what the fuck? And then is evaluated as false, all right? And if your response is now a null, it give you a 0, which is also evaluating as false, right? So you get the idea here. It makes you, and the other is to wrap this into a length, all right? Yeah, but you're assuming here that the length is what? What is the length of this? So when you compare that, for example, with numbers, it is making clear to JavaScript to say, okay, this operation that you're going to compare here, okay, this comparison operations is going to produce now a Boolean value, all right? So I honestly prefer to use now the Boolean. There's some also corner cases with Boolean. For example, if you pass now something like this, a TNN. Okay, so for example, you say Boolean here, Boolean here. There you got it. The /n. It tells you true. You should say what the fuck, similar to this. So if you're passing now escaping characters, or this is telling you that this is true. All right. So it's like what? Oh, because I think this represent is now what this represent, by the way. Invalid escape sequence. I think it's escaping its character. This is for regular expression. I'm not sure what might be. Escape sequence, tab, and new line character. All right. Exactly. Okay. Tab and new line character. Makes a lot of sense. New line character. Okay. Okay. Tab and new line character. Okay. Cool. Cool. And there's also another concept here known as boxing. So anytime that JavaScript wraps values with objects, what it does is to what it does a type coercion. So anytime the JavaScript does a type coercion, okay, it wraps those values into with an object. So so it is safe to say that any time JavaScript coerces, anytime JavaScript runs abstract operation on values, it wraps it into a object, into an object that expose, exactly, it wraps into an object that expose the data and methods of that primitive or object. Okay, when JavaScript does wrap primitive on primitive like hello and method calls, in this case JavaScript temporarily wraps the primitive and in its corresponding object wrapper, string numbers, and to access property method that then discard the wrapper. When JavaScript does not wrap primitive, basic operations, type coercion operations, okay, most internal operations defined in the ECMAScript spec. So when JavaScript does wrap primitive, it's for property access and methods call. So it is more accurate to say JavaScript wraps primitive in objects when you try to access property or method on them, but most other operations work directly with primitive values. The key insight you're getting is that primitive can behave like methods even when they don't actually store these methods themselves. So they can behave exactly. So primitive, okay, so the way how JavaScript wrap values with an object when it does coercion, exactly, the way how JavaScript wrap values with objects when it does type coercion abstract operation, it is called boxing. Boxing specifically refers when JavaScript temporarily wrap a primitive in its corresponding object wrapper to access property, but it's temporary. So while boxing is definitely an important concept in JavaScript type system, it is more specifically about property method access on primitive. Okay. So the way how JavaScript wrap primitive values, exactly, the way how JavaScript wrap values, primitive and objects, with objects, or in an object, when it does type coercion, it is called this. Boxing, wrapping a primitive in its corresponding object rather than So the way JavaScript wrap values with an object, okay, the way how JavaScript wraps a value. Okay, let's go to look at boxing.
I referenced a bit earlier a sort of magical behavior like accessing properties on primitive values. Remember, you access a length on a primitive string or some method on a primitive number, for example. So how does that work? How is it that we access the dot length of some string value here? This DOM element's value is always a string, so how do we access that dot length? Well, it turns out that's called boxing. It's a form of implicit coercion. It's not called out in the same way in the abstract operations, but I think it absolutely in spirit is an implicit coercion. It is saying you have this thing that is not an object and you're trying to use it as if it is an object. Me, JavaScript, I'm going to be helpful and go ahead and make it into an object for you.
You're trying to access this. So boxing is like you're trying to. Exactly, but it's because when it comes to access to that, it's when it comes to access to that.
The only other option would be for the JavaScript to throw an exception that said, you're trying to access a property on a primitive value. I am actually quite happy that JavaScript implicitly coerces these primitives into their object counterparts so that I can access properties and methods on them. I think that makes the code much more clear. If I wanted to write code where I had to turn a primitive into an object just to use it, I'd go write Java. This, I think, is one of the unsung heroes of JavaScript, that it does this boxing and it does it well. Turn a primitive coerces these primitives into their object counterparts so that I can access properties and methods on them. I think that makes the code much more clear. If I wanted to write code where I had to turn a primitive into an object just to use it, I'd go write Java. This, I think, is one of the unsung heroes of JavaScript, that it does this boxing and it does it well. But it is an implicit coercion, yes?
Is that where this notion of everything is an object comes from?
It is. That's exactly what I meant when I was talking in the intro, that people think that everything's an object, and it turns out that things can behave as objects, but that doesn't make them an object. This is not an object. It is a primitive string that has an optimization in it where you can access a property as if it was an object. So these are all examples of coercion that are happening in your programs. And the larger point that I want to make is, whether we call them coercion or we call them conversion, every single language in existence that you've ever programmed in has to deal with type conversions.
But this
boxing, is complete nonsense.
Okay, this boxing stuff is, So the way how JavaScript wraps values, or the way how JavaScript temporarily, all right, the way how JavaScript temporarily wrap a value with an object, all right. So the way or the way how JavaScript temporarily wraps a value with an object so we can have access to it, it is called boxing, bro. Exactly. But it's like that, bro. So the way how JavaScript temporarily say, hey, I'm gonna temporarily, because I'm evaluating this, I'm going to temporarily wrap these values into an object of that primitive, all right? So the way how JavaScript temporarily wraps values in an object or with objects, or wraps values with objects, so we can have access to their methods or data, it is called boxing. Okay? this is something that a lot of people call, or a lot of people say, that in JavaScript everything is an object. Okay? But the reality is that this is something that happened at evaluation. This boxing is something that happened at runtime. Exactly, it occurs at runtimes. So when he's trying to evaluate that expression, his JavaScript say, "Hey, no, wait. I need to do this. You're trying to access to this property, so I'm going to temporarily wrap that value, all right? Whether it's an undefined, null, string, boolean, number, symbol, big int, or object, okay, and allow you to access to this property and methods at that moment." And then the everything is an object is a misconception. The everything is an object is a misconception here. The everything is an object is a misconception here. Another example is like this. And in fact, at the end of the day, all of us needs to deal with the types. Okay? All programming language have type conversion because it is absolutely necessary.
You can write object. This is not an object.
And one of the powerful stuff that I love of JavaScript is that if I want to now work with a particular object.
It is a primitive string that has an optimization in it where you can access a property as if it was an object. So these are all examples of coercion that are happening in your object. It is talking and does this boxing and it does it well. But it is an implicit coercion, yes.
Is that where this notion of everything is an object comes from?
It is. That's exactly what I meant when I was talking in the intro, that people think that everything's an object, and it turns out that things can behave as objects, but that doesn't make them an object. This is not an object. It is a primitive string that has an optimization in it where you can access a property as if it was an object. So these are all examples of coercion that are happening in your programs. And the larger point that I want to make is, whether we call them coercion or we call them conversion, every single language in existence that you've ever programmed in has to deal with type conversions. It is complete nonsense to suggest that you can write valid, reasonable JavaScript programs and not need to deal with type conversion. You're always going to have a string that you need to treat as a number, or a number that you need to treat as a Boolean. You are going to have to deal with conversions, aka coercion. It's absolutely necessary. So, you're going to use it whether you're admitting it or not. You really have no choice.
You have no choice, man. You have no choice.
Because all languages have type conversions, that means all languages have corner cases, including JavaScript.
Exactly.
It is interesting that people like to use JavaScript's corner cases as ammunition against the language as a whole. Just putting blinders on and pretending that other languages don't have those corner cases and we can't make WAP videos about C++, for example, because we definitely can, right? It is impossible to design a system that won't have corner cases. JavaScript has some corner cases. Rather than making WAP videos about them, we should learn those corner cases and learn how to effectively manage work around them.
Do they have more corner cases in other languages?
That's an interesting question, but not one that I think anybody could effectively answer. Because
Okay, so every language has type conversions, corner cases. Okay, and this is something that is used. Yeah. This is something that is used. This is something that is used heavily for that. This is something that is used as ammunition against JavaScript. But the thing is, yeah, But the thing is that all language have to deal with types and corner cases. In fact, if you are developing if you are developing a system, for example, a nutrition plan, a nutrition system, nutrition, exactly. If, for example, if you are hand over a nutrition system or plan, right? Sometimes you are not going to follow that. So sometimes you are going to skip your own rules. I don't know, perhaps the taco days, oh, this is the taco days, such as taco days, right? For example, but I really love this real life analogy of this.
What does even more mean? Are we just going to like keep a count? How can you tell whether this is a distinct different quirk or the same corner case from a different angle? I'm not sure that you could really do that sort of a count. And to the larger point of your question, the only language that I even remotely have any understanding of is JavaScript. So I can't tell you whether it's more or less corner casey than Python. But I know JavaScript has corner cases, and I know you can work around them. Mm-hmm. Here's an example of some of these corner cases. A lot of them have to do with numbers, as I said.
Here are examples of corner cases. A lot of them have to do with numbers. Oh my god.
Here we've got number of empty string. Remember that one? That's the root of all evil. We'll talk about that more in a second.
Yeah.
Nulls and undefined.
Because the string becomes
essentially a lot of the falsy values becoming numbers. Those were a lot of the corner cases.
Now, when you
could have eliminated most of those if we just not made empty string become 0. Most of these would go away. Down at the bottom, there's an interesting example. Almost nobody ever does this, but if you construct an instance of the Boolean object and you give it the primitive value false, it is going to behave as if it is truthy because we don't do a toPrimitive on it. We just ask, is it on the falsy list or not? So it is a falsy object, right?
It is a falsy object, bro. Oh my god. It is a falsy object. Yeah, but most of the time we don't do this. Okay, it is a falsy object. How do you falsify that object? With Boolean, false. But now I think they fixed that. New Boolean, false. Oh, I think they fixed this. Yeah, they fixed it. Okay. Yeah, I think they fixed it. Yeah, I think they fixed it. Yeah, I think they fixed it. Oh no, they don't fix that. It doesn't make sense. It's like if I'm creating is now an instance of this, and I say new Boolean. Exactly, it's like a falsy Boolean. Okay, and it say, hey, if this is a falsy Boolean, yeah, it is a falsy Boolean. It is a falsy object. Oh, crap.
Yet another example. Yet another illustration of why you should never use those particular fundamentals with the new keyword. All right, let's talk about that root of all coercion evil, just to make sure we're absolutely clear here. Not only does the empty string become 0, but any string that's full of white space also becomes 0. Because the toNumber operation first strips off all leading and trailing white space, before doing its coercion. So all examples of white space strings of all forms still all end up producing that same 0. Literally, if I could time travel and fix any one thing about JavaScript, this is the thing I'd fix. I'd go back and tell Brendan, like, no, that's a terrible idea. Don't make empty string become 0, make it become nan. All these other problems would fix themselves. By the way, there are corner cases that are not as obvious because we're not dealing with our typical operations. So remember I said that I thought that the numberification or numerification or whatever that word is, I'll decide on some word at some point, but whatever that is, to numbering a Boolean, I said to you 1s and 0s are a bad idea. And probably all of you said, no, they're a great idea. Well, here's one such example. 1 less than 2. We all know mathematically that that is the case, and so it makes sense that JavaScript gives us true. 2 less than 3 is also
for comparison.
True. But then we try 1 less than 2 less than 3, and we get true, and we think, oh, well, JavaScript is just smart and doing exactly the right thing. Not exactly. Because what's actually happening there is an accident. What's actually happening is that 1 less than true 2 gets evaluated first, which gets evaluated to true line 9.
True.
And then because you have a non-numeric being used with the less than operator, it's going to try to turn it into a number, so it's going to turn it into the number 1, and you accidentally get that 1 is less than 3. That's the reason why true works. And accidents are not a good foundation upon which to build your programs, because look what happens in the next example. We tried the 3 greater than 2 and the 2 greater than 1, but oops, 3 greater than 2 greater than 1, that fails. Because 3 greater than 2 is true. True greater than 1 is 1 greater than 1, which is false. So I think it's a terrible idea for Booleans to implicitly coerce themselves to numbers. And any programming style from 1970 onward that has relied upon the ability to take something that's Boolean and subtract it or add it or something, I think has been taking advantage of that hack, but basically making worse off code. I would make the number coercion of Booleans be nan if I could fix them.
Okay.
So there are corner cases. We know that that's a...
All right. We're going to take a quick pause here. I'll be right back. And we're back. So after that, okay, we now explore the types, the values of the type system. So we went through describing the primitive, the type of operators, the counter cases with those values, such as null, what do we have an object, or the 0.1 plus 0.2 give you now 0.3, give you now is 0.3, 0.0000004, all right? Also, the type of emptiness, whether it is undeclared, undefined, and uninitialized, at least in JavaScript, in these special cases, like the is nan, or positive or negative zeros, and their use cases. So, also how can we detect that particular types? And now the abstract operations, which is this conceptual algorithm that's happening behind the scenes by JavaScript. We don't do that, right? But it's important to at least know is the most common one. The toString, the toNumber, and the toBoolean, right? Of course, there are other type of operations, abstract operations that you can do, but at least this is the most relevant for ourselves. So we have now the toPrimitive, which is try to transform that into a particular primitive, all right? That value into a primitive, or into, even though you try to pass now an object to primitive, it's trying to coerce that into a primitive, and you're going to do that in a recursive way until it finds that primitive value. So most common of that is for numbers and string. It's going to run is this two algorithm, which is if you pass now the hint of a number, and therefore it's going to run is the value of, it's going to evaluate that value. If that produces a number, good. If it's not, a string, okay? Or the toString, which is vice versa. We also look at the toString, or the stringification of primitive, numbers, and that primitive entry is numbers, undefined, all of that, right? As well as objects, as well as objects such as the arrays and how that is transformed into an empty string, okay? If you pass now an array with several values, it transforms that into a 1.2.3. If you pass now undefined or null, it gives you now is this is the stringification of an object. It gives you now commas. What the fuck? Or if you pass now this or this, right? So when you look now at the number, which is a more interesting because it has more corner cases. So first we look at the numberifications of string, okay? So for example, if you pass now a positive or negative 0, it actually transforms that into a 0 or a negative 0. Also, if you pass now strings or point floating numbers, values, or even if you pass now a non-value like a dot, all right, or an hexadecimal value, or a representation of a number in another system, okay, so it will give you now that properly. This is the numberification of a string. And when you look at the numberification of Boolean, okay, true, false, null is transformed into 0, and undefined into an n. And the numberifications of objects, so if you pass now an array, okay, so for objects, you say, okay, well, it makes sense, it's an n. But for arrays, then now it transforms into a 0, right? Or if you pass now a null array or an array with numbers, okay, it's going to now transform into an n. For example, like this, n is not a valid number. If you pass now a null or undefined or an empty array, okay, the numberification of object with array instead of with primitive. If you pass now an empty string, it transforms into a 0. If you pass now null, it transforms into a 0. If you pass into an undefined, it transforms into a 0. But it transforms into an n if you pass now the 1, 2, 3, all right? Or if you have nested arrays, it passes now through 0. And then the to Boolean, that is, as long as you know this falsy list, is much more straightforward, unlike the to Boolean and to number, which is a more algorithmic way of doing stuff. Here is just a lookup table. Look at this. Period, bro. Simple, simple. Now, with that, of these falsy values, truthy or falsy values, right? So as long as this is an empty string, or a 0, or a negative 0, or a positive 0, 0 in general, null, undefined, false, or none, it'll be false. Anything else is true values. It's a number, it's a string, it's an object, it's a symbol, it's a function. Anything else is now a true. Why do we even care about this? Because as we're going to evaluate now this string to number or the number to string in the Boolean cases, when you're going to do this type coercion, string concatenation is the preferred method of doing this, especially when you use the plus array method. There is, of course, no negative string concatenation because that doesn't make sense. But only then, if both of those numbers are now, or if both of those variables are not on a string, it's going to check if that is a number, and if it is, it's going to do this arithmetic operation. So, not only that when it comes to evaluate is places when you have a Boolean value, or when you have a value that is not a Boolean but a Boolean is used, this is when the to Boolean coercion happens. So for example, to avoid any issue, you can do is, hey, I want to wrap this into a Boolean. So for example, in this case, to actually make sure that whatever value that you pass here, all right, now it transformed properly into a 0 and a 1, you name it, right? It transformed that properly. Or in other cases like do while, or conditions, it is preferred to actually pass now or evaluate is an expression here, right? That's what we are calling is this to pass or this, which is like calling is the Boolean. I prefer to use the Boolean because it's more descriptive and it's important to do that. All right. And now the concept of boxing, where there is a misconception that everything is a box in JavaScript, but the reality is that anytime the JavaScript is evaluating the type of a variable, all right? So JavaScript temporarily now wrap the value with an object when you temporarily. So we can have access to their methods or data. Okay. So anytime that you need to access the property and methods from a primitive, or anytime you want to access to the property and methods of a value, JavaScript at runtimes wrap that into a object of that value, whether it's a primitive or an object. Okay, so you can have access to those methods. And I think this is something that, unlike Java, where you want to convert that into a different type, then you need to convert that into that particular object. And this is one of the beauty of this language, I will say. Why? Since we can now is elegantly, and this is huge, this is useful as French toast. So we can now is get the data and access to the data and all the property method that we need to. So it is very compelling, it's very convenient to access to. So this is what boxing is. So again, this is a misconception that everything is an object, but the reality here is that it's not. It's just what happened that at runtime, when that expression is evaluated and you try to access to property and methods, JavaScript is going to evaluate is the type, wrap that into an object temporarily so you can have access to it. Good stuff, JavaScript, good stuff. And now, well, we also look at the corner cases of it that every language has. And then you at some point needs to deal with the type of that, and therefore you say, okay, now let me actually went through the number or the strings or the boolean and also the comparison or the empty values here, right? So why this is the root of all evil? Because if you have an empty value that say, hey, if you're going to transform it into a number for some reason, it's going to be coerced that into a 0, and that 0 is now a falsy value. All right? Or you have to be careful of what happens when you do this kind of coercion to that. Right? So, and also the comparison. And now let's take a look at the philosophy of coercion. You know, I want to explore this and actually take notes out of this. Bueno, All right. Here we are.
It's a reality. There are corner cases. You don't deal with corner cases in any language, but least of all JavaScript, by simply avoiding. You don't avoid the whole mechanism just to get around a couple of corner cases. You have to adapt a coding style that makes your types and the values that are in those types plain and obvious. That's the only effective way to do this. Some people go so far as to use whole type systems, and we'll get into that a little bit later, like TypeScript and stuff. I don't think you have to go that far, but you can adopt a coding style which makes the kinds of types that you're doing much more obvious. I make the claim that a quality JavaScript program is going to have to embrace coercion. You have to make sure that the types involved in every operation are clear. And by the way, that means that you shouldn't be designing all these polymorphic functions that can take any sort of value and do 15 different things based upon the value. You're asking for coercion problems when you do that, and then papering over them, but oh, I use the triple equals. Why not just design a function that only takes numbers, and then make another function that only takes strings? Or make a function that takes numbers and strings, and it's very clear it can only be those two types, and I know what corner cases I have to worry about between numbers and strings. We can choose to be more obvious about how we manage our types, how much we overload, how polymorphic we make our code. We can opt into more problems or opt out of problems as a result.
Exactly, is to make a function to actually
Biggest
handle
takeaway that I want you to get here is that
the
these
corner
are a
cases
fact
of that,
of your
or the
programs,
numbers,
and it is
but you are
within your
more
purview to decide
effective
how much or how little
of that.
you're going to be affected by those facts. That is not to suggest that the only solution to our problem is that everything have to be rigidly, everything's completely statically typed. We have to just basically go write Java or C++ so that we get some kind of like sound type system. That is a reaction to this problem. It is not the reaction I think that is necessary. So the message I'm preaching here is you can learn these systems, use them appropriately, and make them obvious in your code. I do not think that these typing systems are weaknesses. I actually think this is one of JavaScript's strongest qualities. It's an unsung hero. I think it's one of the reasons why JavaScript is the ubiquitous language that it is today, because it has been so palatable to so many different use cases. The first truly multi-paradigm language, and a big
has been so
reason why
palatable for multiple use cases, man.
the ubiquitous language that it is today, because it has been so palatable to so many different use cases. The first, I think it's one of the reasons why JavaScript is the ubiquitous language that it is today.
I do as well. I think JavaScript is so ubiquitous right now is because it's so palatable. Exactly. It's so tasty. Okay, I think JavaScript has reached to this ubiquitous place.
It's I do not think that these typing systems are weaknesses.
I do not think this type of system or coercion systems are weaknesses. Yeah, I don't think this type of systems are weaknesses. And there is a reason why.
I actually think this is one of JavaScript's strongest.
So I don't think this type of systems are weaknesses. And I think the reason why JavaScript has become or has been I think the reason why JavaScript I don't think the type systems are the weakness. I think the reason why JavaScript has been so ubiquitous.
It's an unsung hero. I think it's one of the reasons.
It's the unsung hero. Unsung. is the unsung hero. So I do not think this type of systems are weakness. I think it is the greatest I think it is the greatest powerful or strongest wait, what? I think it is the strongest, especially with all of this coercion, especially with boxing. I do really think that it's very I do not think these type of systems are weakness, and I think it is the strongest quality of JavaScript that is so ubiquitous. Okay, when you talk about ubiquitous, okay, it is so ubiquitous. That word is something that is not being used too much in the present. In Spanish, I mean, es tan ubicuo. So I don't think this type of systems are weaknesses, and I think it is the strongest quality of JavaScript that is so ubiquitous, which makes it palatable. Palatable in Spanish. I know that it's sabroso because I enjoy that. It's tasty, sabrous, it's agradable, sabroso, comestible, disfrutable. So I think this is the strongest quality of JavaScript. The unsung hero that is so ubiquitous, which make it palatable for different applications or from different use cases.
Hero. I think it's one of the reasons why JavaScript is the ubiquitous language that it is today.
So that is so ubiquitous. The unsung hero. That is so ubiquitous in today's day because it makes it palatable. It makes it palatable for different type of applications.
Because it has been so palatable to so many different use
cases. Because it makes so because it is made so palatable for different use cases, man. Use cases like the browser, like the server, to interact with the DOM, or to interact with or to provide interactivity to the browser, or to provide now is processing power on the server, right? Since because it's an interpreted language, it means that, or AKA, it needs to run. So it evaluate line after another. It's not compiled, right? Even though that there are some JavaScript engines that are trying to make that language compile versions, like just-in-time compilation. So they have now transformed a set of JavaScript into bytecodes, and the other is trying to do after optimizations behind the scenes. This is something that I discussed on the JavaScript when I look at the JavaScript engine. The JavaScript engine here. Da, 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 da. The JavaScript. Oh my god, JavaScript's everywhere. Holy moly. I think it's this one. Holy moly, where is that? No, it's not this. Jesus. Computer design node alone. Wow, what if I want to look at the engine in it itself? JavaScript engine anatomy. Oh my god. JavaScript engine here. No. Yeah, the just-in-time compiler. The GIT compiler. Not sure if you have now an image that'll describe that. Exactly. So it takes all of those tokens, it parses that to create the abstract syntax tree, where now some of them transform into bit code and the other is to machine code. But this is the V8 engine. Exactly, this is the V8 engine. Exactly, because here we're looking at a specific engine and what it's doing there. So the V8 engine for sale, JavaScript. Okay, this is one of the implementations of the ECMAScript. Okay. Implementations of the ECMAScript 262. Exactly. There are implementations of this. All right. There are implementations of this. Not sure if this actually is going to show me this. This is the no bindings. Mm-hmm. Mm-hmm. Exactly. This is the implementation of this. Oh, Matthias Bergbein. There you got it. Come on. Come on. Yep. Come on. Is this one? The implementation of that. So the JavaScript code, it passed through a parser that takes all of this token and now is trying to create is this abstract syntax, this information, like that is going to pass now to the interpreter. The interpreter behind the scene is to say, hey, some of them are going to transform into bytecode and the other into optimize by the compiler here, right? So after it got that optimized code, or the bytecode is gonna be used by that. So it has several layers down below. This is one of the things that is quite interesting when it comes to analyze that. I think that might be quite reasonable to look at this. This is the V8 engine. Okay. An ECMA script 262, an implementation of this, right? There you go. It's an implementation of that. So far, so good. Okay. Now, so this is the JavaScript object model. Good. Good. And what's happening here, the JavaScript object model, all right, which is another set of instructions that actually does this kind of stuff. So because this is go beyond the scope of today's video, but it's important to understand that when we are doing this type coercion, is now one of the strongest features or the ability of JavaScript that is now so ubiquitous, that make it so palatable to write, and it's so palatable for different use cases, for many different use cases. So I think this is one of the advantage of the advantage I do not think that the type system is a weakness, and I think this is the strongest quality of the JavaScript, the unsung hero, that is so ubiquitous in today's day. Because it makes so palatable. For different use cases. And I'm part of this, the front end, the browser, the server. So yeah, actually, this is when I find out, even when I have in my college years, I found out this very interesting. This idea that allowed me to communicate with people thousands of kilometers away of myself. And then we can share and exchange knowledge or music or stuff like that. So I love the idea of Spotify and that kind of stuff. Is now giving ourselves is this tremendous expansion in our conscious. I know that might be quite sound trippy. I know, but we have reached to this point is through the accumulations of all of this experience of people that have fought, died, wrote, and live, that we are now is much more aligned with nature. Perhaps some current narratives are not, but for example, we are now living is beyond the 30 years old, and that's a huge improvement. And that's a huge improvement, bro. Right? So most of our life expectancy is to live up to 60, 70, 80, 90. Holy moly, right? While maintaining this physical body of a young people. I will hope to make that possible as much as possible. So I am committed to that, absolutely, because I know that at the end of the day, what I am the only one here, you as well, you know, you are the only main character in your own life, so act accordingly. So you know how all of these things are joining together. And with JavaScript, what we're doing, especially with this philosophy, that's what we talk about, the philosophy of coercion, is that at some point we need to deal with this conversions, and by avoiding the corner cases of coercion is not an effective way to use the tool. That's why you have now, as I put it here, so we need to adopt, okay. So we need, let me put it this here. So we need to adopt is a mindset in which we are now explicitly declare is these type systems and how we're going to write this, you know? It's being explicit about the coding style that made these type planes obvious, man. Quality JavaScript programs embrace coercion, making sure the types involved in every operations are clear. Make sure that every type of operations are clear. Every time that the JavaScript evaluating statement by statement, it is clear of what's going on there.
Use cases. The first truly multi-paradigm language, and a big reason why it has been able to survive multi-paradigm, is because of its type system.
That's interesting.
And that's completely opposite from what every one of my peers and everything else that you've ever heard. Everybody else has always told you this is the worst part of JavaScript, and I'm going to put my foot down and say it's one of the best parts of JavaScript. And if you're not using it, your programs are missing out. And the argument I always get back from people, and some of you may be thinking this at this moment, is, yeah, but even if I sat through your workshop and I learned all these nuances and I read the spec, what about all the junior devs on my code base? They would never understand this stuff. This actually infuriates me almost more than any question I ever get. This mindset that says, well, I'm smart enough, but those junior devs, they're too dumb to understand this stuff. That is complete and total nonsense. I don't know what your backgrounds are, but every one of you is excellent at what you do. You may know more or less about JavaScript, but that doesn't make you dumber and less capable of understanding stuff, less capable of learning things. I do not subscribe to the belief that we should dumb down our code bases to the lowest common denominator. You should absolutely use the tools as effectively as you can. You should be as obvious about how you're using the tools as possible. And when somebody is on the code base who doesn't understand, use it as an opportunity for them to learn. Use code reviews, use a culture of peer-to-peer learning, of pairing together, all of those things to help everybody learn how the tool works better. When you receive a code review and some junior developer did something dumb, like they didn't do a coercion correct, and maybe there's some corner case they didn't know about, you don't reject the code review and say you're dumb. You say, hey, come sit with me for a minute. Let me just talk to you about this corner case that you weren't aware of. Exactly. And if you did this thing instead, we'd avoid that corner case entirely. Now you learned better and they learned better. This is a complete bunk argument. It's a lazy excuse for not wanting to actually do what we ought to do on our developer teams, which is promote that everybody should be learning. Everybody should be headed upward. I don't care where you are. I care what your direction is. Are you headed upward? Are you learning more about your tool?
This is something true, especially if you're going to hire something. Even if you don't own a company, or even if you want to hire somebody in your life, what is the direction that you're going to? Holy fuck, here we go. Fuck. Oh my god. Oh my god. Oh my god. Here we are. Exactly. I don't care about I don't care about your title, man.
Promote that everybody should, and they learned better. Oh, this corner case that you weren't aware of. And if you did this thing instead, we'd avoid that corner case entirely. Now you learned better and they learned better. This is a complete bunk argument. It's a lazy excuse for not wanting to actually do what we ought to do on our developer teams, which is promote that everybody should be learning, everybody should be headed upward. I don't care where you are, I care what your direction is.
Exactly. I don't care about where you are. It means the position. I care where are you going? What is the direction? I care what your direction is. I care what your direction is. And this is also true for myself, man. You know what you're talking about in philosophy? I don't care where you are. I care what your direction is. Are you heading upward?
Are you headed upward? Are you learning more about your tool?
I don't care about where you are. I care about what's your direction. Are you heading towards or upward?
Developer teams, which is promote that everybody should be learning, everybody should be headed upward. I don't care where you are, I care what your direction is. Are you headed upward? Are you learning?
Are you headed? Are you headed upward? Okay. Are you going upward? Are you headed upward? Are you learning? Are you understanding here?
About your tool.
Are you learning about your tool? I don't care about where you are.
This is not an excuse for not using the tools well. It is also not an excuse for being clever, right? Some people say, oh, well, the slippery slope argument here, all I can do is do all this like clever bitwise math, right? I'm using the tool and I'm being clever and I'm doing all of my programming on one line of code the way we used to do in Perl. That's not what I'm saying either. What I'm actually saying is that your code is a form of communication, and there is an effective way to communicate that understands and uses the tool well. If you ask the reader of a code to understand something about the tool so that they can understand that line of code, that is an investment on their part. Make sure that that investment pays off beyond that line of code. Make sure that when they learn how that worked, they're going to see more of that, rather than they learn how you did some weird esoteric bitwise trick, and then they never get to use that ever again. That's a waste of their time. Makes you feel good, but it's a waste of the time. And it's part of the reason why we struggle so much to have good dev culture. Because we're not focused on promoting that everybody should be able to understand. From the person who is 3 weeks into JavaScript to somebody who's been at it for 20 plus years like me, we all ought to be able to interoperate on the same code base and communicate well. Yeah, the junior dev's going to need to learn some stuff, but that's what happens in every job and in every industry. You have to learn some stuff. You don't see an architect saying, well, we're not going to design that building well because we've got an intern on the job. You teach the intern how to build the building well. That's what we need to be doing. We need to be doing it with all parts of JavaScript, but especially the parts that everybody tells you to ignore, like types.
I'm curious what the role of something like JSDoc or other notation standards are. It kind of sounds like there's the issue of writing code for the machine and then writing code for the humans who have to read it.
This is especially with
Sure.
code communications. With JSDoc.
And I'm very persuaded by the arguments about, say, for using explicit coercion.
So
are
your
there
code,
other cases where
your code should
you
describe
counter
is
code would
what it
recommend,
does.
like ancillary tactics like that.
And the
Well,
dog
I
and the dogs.
certainly think if you think
why
about
it does.
coding on the whole, it's a great question, by the way. If you think about coding on the whole
It's a great
as
question
a way to communicate my ideas, then there are lots of ways to communicate ideas. One of the ways is in the code that you write. One of the ways is in the ancillary stuff
Code
that you mentioned, like,
communication.
for example, code comments. Now, some people tell you, no, you should never need code comments. Code should explain itself. You should not have more reliance
Your
upon code comments than the
code
code. And I've seen
should
code bases that are like that,
should
that are
your
so inscrutable
code
that without the code comments,
must, because this
nobody's
is not should. Your
figuring it out.
code must
But code comments are
describe
not a bad thing to be
what it
avoided. They're not like
does.
they're not exposing some weakness of the program. Here's the problem with code
Or
comments.
how
People
it
write
does.
the what in their code comment. I'm sorry,
Okay.
they write the how in their code comment. Like you have a line
Your
that says
code
I++,
must describe what it
and then
does
you
and
say
how it
something
does.
like
The
increment
comment
code comment.
must describe.
I know it's incrementing I can see that. Here's
must
what I want
describe
the code comment to tell
why
me. Why?
it
Why do you need
does.
to increment? And why only by 1? Why not by 2 or 12? Tell me why. And sometimes maybe tell me how, but don't tell me what. That's what the code's for. So yes, you can communicate well with your code. If you did a JS doc on this function and said these two parameters receive either strings or numbers, then you're very clearly signaling to everybody, be aware that some coercion may happen, but it's only between strings and numbers. And so we know we have narrowed down the scope of corner cases that we need to be concerned about. Absolutely, code comments can be useful. I wouldn't rely entirely on them. I think there's lots of things we can do in our code to be obvious. There is a temptation to believe, and sort of a cult feeling among the community, most developers tend to think that implicit mechanisms are magical. That when something happens underneath the scenes and it wasn't obvious, then it's some sort of magic, and we tend to equate magic with bad, evil. Like this is not good because I can't understand what's happening. And this is a predominant reason why that anti-coercion perspective exists, is because people feel like the implicitness of coercion is the downfall, where they point to the explicitness of typecasting in something like Java or C++, and then they say you would never automatically convert an integer into a float or whatever, but JavaScript does all this sort of automatic stuff, and then they say, well, that's a weakness of JavaScript, so because it's magical and bad. I don't think it's either of those things. I think that we should think about implicitness as abstraction. Not all abstractions are good, but some abstractions are necessary.
Mm-hmm.
Implicitness, and we're not
all
dealing with
abstractions
functional
are
programming
good.
here. This is not this
For
course.
some
that's a
abstractions
different
are
course.
necessary.
Here's a plug. You can check out my functional programming course. But within functional programming, you use abstraction all over the place.
Yeah.
And it turns out that the declarative style of coding is actually more implicit. So implicitness is not bad. It is the proper usage of abstraction. In other words, we want to hide key unnecessary details. Why?
When you are
Because that
doing is
refocuses
this
the reader on the
point-free
important stuff.
Style.
We're not distracting them with the stuff that they don't need. We want to focus them. We want to increase the clarity of the code by refocusing. So some of the implicit nature of JavaScript's type system is sketchy, but some of it is quite useful. For example, the boxing, that's implicit, but also very useful because the distraction of having to cast it into an object is, what I would argue, in most cases, an unnecessary detail that the reader doesn't need. And that's actually at the DNA of JavaScript. Part of the reason JavaScript has such a low barrier to entry is because it doesn't force the reader to deal with a bunch of unnecessary detail. It betrays JavaScript's DNA to suggest that all those implicit things are things that we should avoid. So here, if I'm writing string to make it super obvious that I'm going to make this thing into a string, I don't know, I think that's distracting. I think I would just drop in the number and be perfectly happy because I know that number is never in any of those corner cases where something could
Exactly,
be
coercion implicit can
Maybe
be
I've
good
already
sometimes.
checked to make sure that num students
Similar
is not
to the
nan.
functional programming here.
All the
Similar
other
to the
numbers
functional
that could
programming is like, hey, I know that the shape of this function is this, and that'll be it.
possibly be other than -0 and nan. Those are my only corner cases that I need to worry about here. So if I have if statements that deal with those corner cases, then this line of code, line 4, is actually better communication because it properly lets JavaScript abstract the detail that's not necessary to deal with at that moment. Here's another example. The less than operator, we talked about how it coerces things into numbers. Sometimes you want to go ahead and make sure that both of them are a number so that you don't get something weird. For example, if both of them are strings, it doesn't turn them both into numbers. The less than operator does an alphanumeric comparison. So there's a corner case. If you could possibly have a less than applied to two strings, you probably do want to make sure that they're both numbers. But if I'm in a place of the code where I know at least one of them is definitely a number, well, then I know the other one's going to become a number. So maybe it's not necessary to force you to read the fact that I'm making them both numbers. Maybe it's okay to let that less than operator do the coercion for me. These are not hard and fast rules. These are trying to train you to think like this, to analyze. And if you are in a place where you have the choice to use coercion, but it's not obvious, it's within your purview to make it obvious. Make it obvious that they're both numbers, and therefore I don't need to worry about explicitly casting them. It's just already obvious that they're both numbers. If you communicate that intent, it's not going to trip up other readers of the code. Really the question is showing these extra details helpful to the reader or not? Sometimes yes, sometimes no. Basically, I'm asking you to be critical, analytical thinkers. To be an engineer and not a code monkey, okay? Doug Crockford famously said, if a feature is sometimes useful and sometimes dangerous, and if there's a better option, then always use the better option. As a matter of fact, almost all of the good parts stems from this one foundational perspective. I respect what Doug has done for our industry, but I couldn't disagree more with this perspective.
And the other is implicit is not always bad. Implicit coercion. Exactly, implicit coercion. Use it when, exactly, implicit coercion. Using when there is no room for confusion. Okay, for type confusion, right? Use it when there is no room for type confusion. So a good example of this is this one, right? And another example of this is here with numbers, okay?
Partially, I disagree with this because we throw this principle around and we don't even say what we mean by these words. So what is useful and what is dangerous? Only what Doug thinks is useful and dangerous? Is there some universal definition for useful and dangerous?
In Crockford, Doug Crockford is the founder, Doug Crockford, okay? So Doug Crockford is the creator of a JSON. Holy shit. Oh my god. Holy French toast, bro. Holy French toast, good bro. The good part. Oh, okay, the good part. In 2008, how JavaScript work? And a million zeros. And a million and one random digit. A million nines. And all of these kind of books. Oh, interesting. JavaScript, the good parts. Crockford. Most programming languages contain good and bad parts. Here we start with this statement that it's not true, bro. It's not true. There is no good, there is no bad stuff. But I think that as a society, we need to develop this kind of conventions to make ourselves, to transfer this. But the thing is that programming language, they don't contain good or bad stuff. It is how do you process that stuff? It how does affect you, right? But JavaScript has more than it is share of the bad, having been developed and released in a hurry before it could be refined. These authoritative books scrap away these bad features to reveal a subset of JavaScript that are more reliable, readable, and maintainable than language as a whole. A subset you can use to create truly extensive, efficient code. Considered the JavaScript expert by many people in the developer community, author Douglas Crockford identified the abundance of good ideas that make JavaScript and outstanding object programming so palatable for these different use cases, such as functions, loose typing, dynamic object, and an expressive object. Literal notation. Unfortunately, these good ideas are mixed in with bad and down times awful ideas, like a programming model based on global values. When Java applets fail, JavaScript becomes the language of the web by default. This is one of the reasons of why I really love about JavaScript. It is the language of the interaction, interactivity. Interactivity not only in who do you think is interacting? Because at the end of the day, it's humans that are interacting through these devices. Laptop, mobile, your Apple Watch, or your watch right now. Making its popularity almost completely independent of its qualities as a programming language. In JavaScript, the good part, Crawford finally digs through the streaming and pile of good intention, blah, blah. Syntax, object function, inheritance, array, regular expression, methods, styles, and beautiful features. Again, this is in 2008. The other is the eloquent JavaScript. And the third edition. That's interesting. Well, how old is this? It doesn't tell me is that, well, when this was published, bro. Oh my god, for real? Well, in any case, you don't want to tell me. Eloquent 3rd edition. No problem. 2018. Okay, value types and operators, pro instruction functions. Okay, binding and scope, nested scope, function as value, declaration notation, arrow functions. Oh, it is more updated. The call stack. Yep, it is way much more updated. Well, 2018. Kind of. And it's interesting that this book is open source, bro. Drawing a canvas. Oh, Eloquent JavaScript 4th edition, 2024. Interesting. And the no par. The file system model, the HTTP model, and the strings here. A file server. Skill sharing website. Okay. Who made this? Okay. Anyway, yes. Oh crap. Okay. Interesting. Okay, cool. So Doc Crockford.
Better option. How do we define better option? Is there some universal standard by which we measure better? This statement is not useful in its abstract sense. It's used in its abstract sense, but it's not useful. So let me put my mark in the sand and tell you what I mean by those words. Okay? Number one, useful is when the reader is focused on what's important. And dangerous is when the reader can't tell what's going to happen. And better is when the reader understands the code. So you could take that principle and apply this specific meaning to it, but you can't simply throw that sentence around as a justification for why you avoid learning an entire part of the language. The big crux here is...
That's silly. That doesn't mean that they don't exist.
In Doug's opinion, there's a better option, which is just don't learn and understand types. My perspective is that's not better at all, because it leads to developers systemically not understanding their code. It's not better because it leads to less understanding. The takeaway I want you to get here is that it is irresponsible to knowingly avoid usage of a feature that can and does improve code readability. It is not just simply you're not taking advantage of some great things. You are actually making code worse off. Not only for your future self, but for all other people that need to read and maintain the code. That tool exists, and it's irresponsible not to learn and use it. Let's take a look at...
So from all of this, okay, from the philosophy of coercion and why this is one of the strongest features of the language, because it makes it so palatable to cover or to be used in different use cases, right? Because the level of barrier is so low, so you don't have to actually worry about a lot of things. For example, some implicit stuff like boxings, you just give it for granted, and this is useful. And this is the reason why it is important to understanding the features, which is something that the Good Part book from Crockford say. If a feature is something useful in this context, that is, hey, it improves readability, okay, and sometimes dangerous, which is it doesn't give me the outcomes that I need to. I can determine the outcome, and if there is a better option, and if there is a better, or in other words, to describe the intent of the code option, then always use the better option. So if there is a feature, sometimes that is, if it's a feature is sometimes useful and dangerous. If a feature is sometimes is important, if a feature is sometimes is important because it's focused on what it needs to, and dangerous because it doesn't give you the expected outcome, all right, then use the better option, which is when the reader understands the code. So in other words, it's like it is irresponsible to knowingly avoid uses of features that can improve code readability. So this is Kyle Simpson making his case, and that'll be all for this video. Take care. Bye bye.